All right, the second part of 3.2, I want to talk about with respect to quadratics, and I want to show you the area model first. So the problems that we're going to work on this section are all modeling real situations, but I'm going to start with a very simple one for you first. Quadratics, the x squared part, the a x squared plus bx plus c, that comes from us having a square here. So let's look at that equation and think about it in terms of area. So we know the area of a rectangle is length times width, whichever one you want to call width, but we multiply however big this side is by however big this side is. So here's an area model where I've said x times 4 minus x represents the area of this quadrilateral. That's where quadratic comes from. So if we multiply that out, like distribute, we get 4x minus x squared. And this, it now looks like a quadratic. If we rearrange it so that we have negative x squared first, so it looks like how we normally write a quadratic in standard form with the highest degree first, then we know that this quadratic has a down parabola shape, and we could pick out A, B, and C. So this big A means area. If I'm talking about the quadratic formula, these lowercase a, b, and c, for this equation, I would say that a equals -1, b equals 4, and c equals 0, because there's not a 0 there. Before I go and graph this and talk about mins and maxes and the vertex being at negative b over 2a again, that's coming back in this section, let's look at some actual numbers for this, all right? So let's look at area if x was 0. So in your mind, you're going to pretend that this is like a fence, and this is where you're going to keep your dog and or a rabbit, something smaller if you like. If x is 0, the actual shape of this is going to be 4, because 4 minus 0 is 4. So it's going to have, I guess I can move this over so it'll have the exact same width. So this is x equals 0. But the this direction, I don't have any x because x is 0. So there's actually no area at all here. So in this case, area equals 0. And you can see nothing lives in that little square because it's not even a square. There's no opening there. At x equals 1, we now have 4 minus 1 up here, so that's shorter. And then this way we have 1. So we have a small square, a rectangle, like a running path, if you will, or like a lap pool, if you were making a pool out of this. So the area equals 3 times 1, or 3, whatever, feet squared, if you will. So this is feet squared, this is feet squared. If we said x equals 2, we've got 4 minus 2, but in this direction we also have 2. So now we have at least a square that's 2 by 2, area equals 4 feet square. So my area went from 0 to 3 to 4. And if I go in the other direction, and what I mean is, you'll see it when I draw this out, if x equals 3, then the top side is going to be 4 minus 3 is just 1, but then the downside is going to be 3. And it's going to be 1 times 3, area will be 3 feet squared again. So it went from 0 up to 3, up to 4, and then back down to 3, because it's in the shape of a parabola. So I'm going to show you that on a graph in a second, but I wanted you to have a visual of what area looks like. So it actually changes the shape of the area model for this if we were making a rabbit pen. Okay, so we'd have long and skinny. This one's also long and skinny, but the other direction. This one's a square and has the most area so far. We didn't put any decimals in there, so there could be other choices. But what we're trying to do is represent any kind of fence we could make here, and we want to find the one that has the largest possible area. So let's look at it on a calculator and see what the graph means for us. I'm going to put the same equation into the calculator. So I've got x times 4 minus x. X parentheses 4 minus x parentheses. And I'm going to graph this knowing that x can't be any smaller than 0. So I'm going to change my window to be from 0 to 10 and graph. So what this graph represents is if x was 0, then I have 0 area. If x is 1, then we have 3 for the area. The line here represents the multiplication or area. If we go to 2 for x, we're up here at 4 for the area. Then it starts going down again. And if we go all the way to 4, we don't have area again. So looking at our picture, if we went down to 4 for x, which I didn't write here, but I can, if x equals 4 again, I have 4 minus 4 on the top, I have 0, and then I'd have 4 on this side. So I just have a straight line, but in the other direction. So these are like opposite direction for the fences, but there's no room for anything to live in there. So my area is 0 here. So the area model is at 0, 0, we have 0 area. At 2, we went up to 4, 1, 2, 3, 4. And then it goes back down again, and it's 0 at 4 again. So this represents all the y values equal the area. This is the maximum area, 2 to 4. And you can see it on my graph here. It's here at 2. That's the highest value, which represents area. Now, how does that help us? Well, this is a lot of work to talk about this one example when we've already said that if you have standard form, which is the standard form, you can use the equation x equals negative b over 2a to find where or when the equation, the f of x or a of x or whatever you're doing, has a vertex. And the vertex represents the minimum or the maximum, depending on if it's an up parabola or down parabola. So I've done a lot of extra work in this problem that you're not going to have to do. I just want some of the math that we do to make sense for you so that you know what it is. That we're not just plugging in magic numbers. They actually represent part of the quadratic formula, which we derived last year. And it goes with this equation. We can find this value in the middle by saying x equals negative b over 2a. In this particular equation, b is 4. So that's going to be negative 4 over 2, that's this 2, times a, which is negative 1, which is negative 4 over negative 2, which is 2. What that means is at 2, the area function has a vertex. In this case, it's a down parabola. This vertex is a maximum. We can plug in 2, so we can say area at 2 equals negative 2 squared plus 4 times 2. That's negative 4 plus 8 equals 4. This is area equals 4. Area equals 4 when x equals 2, and it's a maximum. So all of these notes, this is just to help you along to understand that modeling equation has real life images and pictures that you can think about what's happening as you change the x value to different numbers. And this is how it's graphed. All right, let's look at some of the examples in the book. Okay, our first example, written as a word problem. We're going to model this, all these words, into math. Find a pair of numbers whose product, so that means multiplication, is a maximum. So we're going to use this one as a quadratic because that's how we know how to find maximums with negative b over 2a. If the pair has a sum of 10, so this is a second piece of information that we're going to need It's like the constraint. It's like the like our other equation we said a side was x minus 4. It had to be that way. So the pair of numbers, let's say they're x and y, we don't know what they are, have a sum, and that's why I said x plus y. When we add them together, we get 10. So this is always true, x plus y equals 10. There's a whole bunch of numbers that do that. They could be 1 plus 9. They could be 0 plus 10. They could be 4.5 and 5.5. There's a whole bunch of numbers that could be. But these numbers also have a maximum multiplication. So this is the function we're going to maximize if we say that we're multiplying x times y. Now we've got two equations here. What we need is to use this one. This one we're going to call the constraint or given substitution. That we're going to somehow apply this to our function. Now, I don't have x squared yet, so I need that to look like a quadratic before I can use negative b over 2a. So what needs to happen is that instead of having y here, I need to substitute. I'm going to use substitution method. We talked about substitution method with elimination method last year. We're going to use substitution method here to insert this piece of information into this equation. So if I know that x plus y equals 10, I can rewrite it to say that y is equal to 10 minus x. I can add the negative x to both sides and get 10 minus x. And now I'm going to rewrite f of x to be x times 10 minus x. So I substitute the 10 minus x in here for y. Now, why do I want to do that? Because now I can tell that it's a quadratic. If you multiply it out, you have 10x minus x squared, or negative x squared plus 10x, and now we can use the negative b over 2a. This is going to have a maximum where x equals negative b over 2a. So x equals negative b, so 10, over 2 times negative 1, that's 10 over 2 because the negatives cancel each other out, so x is 5. If x is 5, then since we also know that x plus y equals 10, if we plug that 5 in, 5 plus y equals 10, y must be 5. So the numbers that produce a maximum who also have this piece of information true are x equals 5 and y equals 5. So the numbers are 5 and 5. Their product is 25. We're going to do this again with a different sort of problem. I'm going to give you a sec to work it yourself and see if you can follow the same sort of logic. Okay, example 2. Fred found 22 feet of fencing in the shed, and he wants to make a chicken pen of maximum area. What are the dimensions of the pen? First, what I want you to do, I want you to pause the video and write down the key bits of information, including a picture. Okay, again, I don't want you to just watch me work the problem. I want you to try to work it on your own and see what bits and pieces you can come up with by yourself. So if you haven't already, please pause the video, write down the key points, and draw a picture. All right, so we're back. We're going to say we have 22 feet of fence. This is the key points you would write down. We need area of a side to be a max. So we need this to be the quadratic formula that has a squared in it, that has area. So we can use negative b over 2a. I'm going to draw a picture of a, these are going to be rectangles, okay? So that was not given in the equation, but he's not making a circular one, he's making a rectangle. I do know that if I have a rectangle, I'm going to have two sides are x and x and two sides are y and y. I don't know what they are, but I do know that if I use all the 22 feet, then I'm going to say that this side plus this side plus this side, but this side, which is x plus x is 2x, y plus y is 2y equals 22 feet. That would be my constraint. I don't have any more fencing than this. I can't make it any larger because I only have, that's why I'm calling them constraints, I only have 22 feet of fencing. Now, area, the area of this same shape, the inside is going to be x times y. So similar to the last problem that we did. X times y. And similar to the last problem we did, I need to rearrange this to be y equals so that I can substitute something in for y. I need this to have x squared in it, and right now it has x times y. So I need it all to be in terms of x. We're going to use this to rearrange it. I'm going to say that 2y equals 22 minus 2x. Y will be by itself when I divide everything by 2. So y is equal to 11 minus x. So now I can use that here and say the area of this pen is equal to x on one side and y, but I'm going to replace y with 11 minus x. Now this is a quadratic. It's 11x minus x squared. I've been rewriting it so that the x squared is first so that I can get my negative b over 2a correct. And so this is going to be a maximum, and I know that this negative means that I'm going to graph this and have a negative, so I'll have a number on the top, a maximum. It's going to be at x equals negative b over 2a. And I seriously want you to write that every single time so that you can remember what the equation is. So negative b is going to be negative 11 over 2 times negative 1, which is going to be 11 halves. So at 5.5, these are equivalent. At 5.5, I have one side. So x equals 5.5. This equals 5.5. That is 11 if you add them together. So that means these two sides are also going to have to add up to be 11. So this will also be 5.5. But if you're not sure, all you have to do is plug in here. So we know what x is. This is x equals 5.5. We can write y equals 11 and plug in x right here. So 5.5 or 11 halves, 5.5. And we would get 11 minus 5.5 is 5.5. So the dimensions of the pen are going to be 5.5 times 5.5. Now we needed to actually do some math here. We could have guessed a square, but we couldn't just do an XY chart and test a whole bunch of things like we did in this problem. We happened upon the maximum value here because we plugged in the integers that went between 4 and 4, so 0 and 4. But this one came up with a decimal, so we need to use the equation to be able to find the answer to this one. Some of the other problems that we have in this section are more straightforward. So they might give you an equation and you need to find the max or the min. So let's look at one of those. Okay, example 3. The total revenue for Thompson Studio Apartments is R of x for revenue. Revenue of x equals 10x minus 0.1x squared. And x means the number of rooms rented. What is the number of rooms that creates the most revenue? So again, what I want you to do is not necessarily copy this entire problem word for word, but write down the equation, write down what R and X mean, and then see if you can find the X value that makes a maximum revenue. Your final answer should be in revenue. See if you can work this problem from beginning to end, and then I'll go through it with you and tell you all the things that you should have had written down to get there. Okay, we're back. So this would be what you'd see in the book. You write down on your paper the equation. R of x equals 10x minus 0.1 x squared. You should write down the total revenue. This is revenue. You should write this. And then they tell you that X means number of rooms. So this is a function where what happens, the input value, what you put in here is if you rent 0 rooms, this is 0 and this is 0, you have 0 revenue. If you rent 1 room, you put 1 here and you have 10 minus 0.1, and that tells you how much money you've made. And then 2, and then 3, okay? So this is a quadratic, meaning that if we graphed it, it would have a shape like this because it has a negative in front of the x squared. And you're looking for right here, you want to look for the number of rooms, that's on the x-axis. So on your paper, you should have this and the description. Now this is me explaining in case you're wondering what we're doing. You may or may not have this written down. But the idea that it's a down parabola is important, and we're finding the maximum. Once we find which room gives us the maximum, we can plug that in, and the number out here, the y value, is the revenue or the money made. And how do we do that? Simply, negative b over 2a gives us the x value. So I'm not going to rearrange this one. Negative b, that's the 10, so that's negative 10 over 2 times negative 0.1, negative, I'm going to change that to 1/10, because in a second I'm going to flip over my fractions. So 0.1 and 1/10 mean the same thing. The two negatives cancel. I have 2 and 10 cancel, giving me 5. I have 5 over 1/10, which is 5 times 10 over 1. When you divide by a fraction, you flip and multiply. And so we get 50. So if this is in dollars, then, I'm sorry, if this is, this can't be in dollars because X is the number of rooms. So what does X mean? X means 50 rooms. I don't have revenue yet. It's important that you make notes about stuff. So X is rooms. I was about to say money and I went and fixed it because I know what X is. X is the number of rooms, so 50 rooms. And at 50 rooms, how much money do we make? Question mark. We put that back into the equation and we say the revenue at 50 rooms, R of 50, equals 10 times 50 minus 0.1 times 50 squared. I don't mind at all if you take out your calculator at this point and figure out the math part. So I'm going to get out of my graph. I'm going to make this a little bit smaller, which is really this way. There we go. Okay, so now I'm going to plug in my numbers right here. I've got 10 times 50, subtract 0.1, parentheses, 50, parentheses, squared. And it's just going to square what's in the parentheses there, and I get 250. So if this is one night at a hotel, they would make $250 if they rent 50 rooms. And that equation takes into consideration all the things that go into renting a room. That's why it has that minus there. So you're given an equation. You need to know what the different pieces mean. You're going to use negative b over 2a. That will tell you the x value. You plug that back in and find the function value. And because you know that this is a down parabola, you know this is a maximum. Maximum revenue. All right, one more type of example, and then you can work on your problems. All right, many of your problems that you're going to practice have this kind of equation in them. You can see that it's still a quadratic. We're dealing with that. But this equation has a special meaning. It is the height at time t. And this number represents what happens to something in motion. So if you throw something up, it comes down, right, because of gravity. So this negative 16t squared is the effect of gravity on something in motion in the air. So this is height. So we're talking about throwing something up or having it fall down. This V sub 0t means at time 0. That's why there's a 0 there. Sub 0. It's like opposite an exponent. It's sub. At time 0, this is the velocity of whatever the object is. So if it's a ball and it's thrown, if it's thrown up or down or shot out of a cannon or whatever it is, it's the speed that it's thrown. So speed or velocity. H sub 0 means at time 0, the object was at what height. So this is the height when you're starting your problem. So if you're talking about falling off a cliff, it would be how high the cliff is, or throwing a ball from the top of a stadium. The top of the stadium would be 100 feet. If you threw the ball, you throw it at whatever miles per hour you throw it at, and this is respect to gravity. So I guess it wouldn't be miles per hour because this is in feet per second squared. All right, so we're going to look at problems that we have to say, okay, here's the whole problem. Here's gravity. Here's if it's thrown or just dropped. If it was dropped, then V sub 0, we don't need the T there, the V sub 0 would be 0. Height, this is if you're standing and you throw it, your hand might be at 3 feet. You don't throw from the ground. So the height that you throw something, or you could be at the top of a building, which is 100 feet tall, something like that. Also, this whole function is height at time t. If at the end of the time it lands on the ground, then this landing on the ground would be 0. Would equal 0. So those kind of ideas. I just want to talk about the equations so you can work these problems successfully. All right, so let's plug in from this actual example. Buddy throws a ball from the top of a 3-story building, about 40 feet, at a velocity of 20 feet per second. What is the maximum height of the ball? So he's throwing it up. He throws it up. And so he's standing on the top of a 3-story building, and he throws it up, and then gravity makes it fall down, okay? So we're looking for how high it is. It's going to start at 40 feet, we know that, but it's going to go higher because he's throwing it. And so we're going to plug everything we know into the equation. H of t equals negative 16t squared. This doesn't change, that's gravity for anything you throw. Plus the initial velocity times time, plus h sub 0. So height, where he starts to throw it, is the 40 feet given in the problem, so we're going to replace that. Velocity is how fast he throws it, so that's the 20 feet. So that's 20. It has to be multiplied by time. And negative 16t squared doesn't change. That equals plus. So this represents the sort of curve of our ball, and it's going to have a maximum where the t value, again, this is not an x, it's not written in x, but the same input value equals negative b over 2a. So that would be negative 20 over 2 times negative 16, and that is going to be negative 10. I'll leave it as 20 and reduce the whole thing. Negative 20 over negative 32. 4 goes 5 times, and 4 goes 8, and I changed it to plus. So at 5/8 of a second, because we're in seconds here, then this reaches its max, and then it starts to come back down. So the maximum height, this is the time. The question is, what is the maximum height? Question mark. So we have to take time and put it back into the function to find out the y value or the height. So we're going to go plug in h of 5/8 into the equation, negative 16 5/8 squared, plus 20 times 5/8 plus 40. So you have to keep in mind where you are in the equation. We found time. This is time, t for time. We have to use time in the height equation to see what happens. So we pull out our calculator and we do this math, which is perfectly fine. So our calculator here, I'm going to clear it out. So I've got negative 16 parentheses 5/8 squared, 5 divided by 8 parentheses squared, plus 20 times 5/8 plus 40. So it's going to go up another 6 1/4 feet. So the height at time equals 5/8 seconds is 46.25 feet. This was feet. Everything was in feet. So there are some questions where you're going to use this base equation and you're going to plug in the information that they give you in order to work the problem. So if it's a height question, use this equation. If they give you a question in the problem, use that equation. Plug in negative b over 2a, and then make sure you understand what the units are that go with that, whether you're looking for the time or whether you're looking for the height, so that you can make sure you answer the question they give you. All right, please make a note of whatever ones you have questions about. I do want to see in your work, I don't need to see you write the entire problem out, but I do need to see you write the initial equation, whatever it is, and try to plug some stuff in. Maybe you should try to sketch a picture if it's not making sense for you. The more you draw about it and try the problem, the more it will make sense to you. Word problems do not have to be impossible. You have to try them and give them your best shot, and you'll be amazed at what you can do. And you do feel very successful after you've worked a bunch of word problems and had good success with them. Okay, so let me know what questions you have. Until next time.